Alright, welcome back. So in this video, we are just going to wrap up by doing an example using shell method. So I've drawn the region here that we are going to revolve, and this is actually a problem I did in one of my other videos, but we used washers in that video. So I just want to show you here how shell method works to find the same region's volume from the solid of revolution. And honestly, I think this way is a lot easier for this given problem, so it's nice to see it in comparison to the washer method. So we are taking this solid of revolution, it's the y equals x cubed and x equals 2 revolved around the y-axis. So to do shells, we're going to be taking vertical bars here and revolving them around, and so they're going to draw out these little shells. So I've drawn this picture here for us just to hopefully make some connections between the little shape and what we're doing. So we're starting with this little rectangle, and then it gets revolved around to make this shell that we're going to be adding the volumes of. So this shell has a little width of dx, and then it has a height that goes from the base up to the top of the function. So that's going to be from x cubed, that's the top of the function, down to just 0. So here there really isn't like a bottom function, it's just going like down to the x-axis. So we can write x cubed minus 0, but it's really just like x cubed. And that's just because this horizontal axis is like y equals 0. So you can think of x cubed minus 0 if you want, if that's helpful. So to set up the area of shells, we use our formula. So we can remember we're thinking about unraveling this little shell and taking the volume of it. So my x values go from 0 up to 2. So we're starting at 0 and going up to 2. Then we do 2 pi times the radius. The radius here is just x, since we'd be going from 0 out to some value x. Then we do the top function minus the bottom function, so x cubed minus 0. And then we multiply by the width, which is dx. Okay, so honestly, we've already set this up. We just have to simplify and evaluate. So we're going from 0 to 2, and I am going to multiply that x cubed by the x, and so I'm getting x to the 4th. All right, we are already ready to integrate. It tells me this is going to go a lot faster than some of the other integration problems we've done. So I add 1 to the exponent and divide by that new exponent. So I have 2 pi times 1/5 x to the 5th, and we're going from 0 to 2. I substitute in 2 first, so I have 2 to the 5th, and then I subtract off what happens when I do 0, so 0 to the 5th. That second term is going to go away since it has a 0 in it, so I'm just left with the first term. So I have 2 pi times 1/5 times 2 to the 5th, which is 32. So 32 times 2 is 64, divided by that 5. Pi, so I have 64 over 5 pi, and we actually did it. That is our volume of the shape. If you have been following through the videos, you know that we did this problem for the washer method, and you can go back to that and see that we got the same answer using washer method for this volume. But I think this is a much easier way to do it. It didn't involve us solving for the other variable or anything. We could just do dx with our x cubed as the top function. Okay. So that's it. That's just this example, very quick. Remember, you use shell method just like you'd use disk or washer, except you use it when you want to revolve around one of the axes but use the other variable. So if you want to revolve around the y-axis but you want to use x, you can use shell. Or if you want to revolve around x but you'd like to use y as the integration variable, you can use shell method. Okay, that's it for this video. Thanks so much for watching, and I will talk to you in the next one.